This video covers everything we did in class on Wednesday, September 29th. Today we were focused on Lesson 9, creating scale drawings. And specifically, we're going to focus on Activity 1 and Activity 2. There's a to-do list above this video of everything you need to accomplish to make up class today, so make sure you follow that checklist closely. First, make sure that you have ClassKick open. That's the other link in the asynchronous work folder, so that you can follow along with this video and complete your classwork. Our first activity is 9.1 number talk, which is greater. Without calculating, decide which quotient is greater. I want you to pause this video and choose one of these problems. Choose any of the three problems and circle it. Then, once you've circled your problem, I want you to explain which quotient, and remember that word quotient means answer, is larger, and why. You should be able to tell which quotient is larger without actually completing the video. So one more time, your directions are to pause this video, circle one problem, and answer it without dividing. Use a full sentence and use that typing tool in ClassKick. Go. Okay, so let's talk about a few of these examples. 11 divided by 23, or 7 divided by 13. Well, there's a few things that we could notice without dividing. I know that 11 is a little bit less than half of 23. In contrast, I know that 7 is more than half of 13. So, because I know that 7 is more than half, while 11 is less than half, that means that 7 divided by 13 is going to get a larger quotient. Because 7 over 13 is greater than 1/2, whereas 11 over 23 is less than 1/2. We could write that out formally like this. 11 over 23 is less than 1/2, and 7 over 13 is greater than 1/2. Now, we'd want to use a similar thought process when thinking about the next question. 0.63 divided by 2 and 0.55 divided by 3. Here's how I would think of this one. 0.63 and 0.55 are pretty similar. 0.63 is a little bit bigger, and we're only splitting 0.63 into two groups. 0.63, we're splitting up into two groups. Now in contrast, we're splitting 0.55 up into three groups. So we're splitting it between three people. We know that the groups we make from 0.63 are going to be larger than the groups that we make from 0.55, because when we split up 0.55, we need to make more groups, which means that each person is going to get less. Another way to think about this is if you split 63 cents between only two people, but you split less money, 55 cents, between three people. The second situation, 55 cents between three people, is going to give you less money. We mostly focused on those two during class. If you answered the third one, that's great. And we're going to talk about division of fractions again in a couple of weeks. So, if at this point you haven't answered 9.1 with a full sentence, please pause this video and answer 9.1 before you listen to what we did on 9.2. Okay, 9.2 is called bedroom floor plan. It says, here's a rough sketch of Noah's bedroom, not a scale drawing. So this is not a scale drawing. Now, Noah wants to create a floor plan that is a scale drawing. The actual length of wall C, and wall C is right here, is 4 meters. To represent wall C, Noah draws a segment 16 centimeters long. So we can write that like this. 16 centimeters represents 4 meters. And that's what Noah is doing in his drawing. Now the question is, what scale is he using? Explain or show your reasoning. Now remember, that word scale means the ratio between the drawing and real life. So for example, yesterday, or I think it was on Monday, we talked about a scale factor of 1 to 5, or maybe it was 1 to 4, but 1 inch represented 4 feet in real life. And this is a similar situation. This time 16 centimeters represents 4 meters. So we can write the scale like this. The scale is 16 centimeters to 4 meters, which we can also simplify to be in terms of 1 meter, because we divided 4 by 4 to get 1, and so we can divide 16 by 4 to get 4. And either way you think of it, it has the same meaning. If you think about a double number line, which is one way we've been representing these problems, where we have centimeters and meters. If 1 meter is 4 centimeters, 2 meters is 8 centimeters, 3 meters is 12 centimeters, and 4 meters is 16 centimeters. So go ahead and pause this video, answer question 1. We just did it together in the video, so all you need to do is summarize what I talked about. You can always rewind to listen to me do it again, or pause to look at what's written on my screen. When you're finished, come back and we'll go over question 2. Okay, so at this point you should have answered question 1. Question 2 says, find another way to express the scale. Now, we already have a tool right here to help us express the scale differently. So if the original scale is 4 centimeters, or is 16 centimeters to 4 meters, that's the original scale, write down another way that we can express that scale in question 2. So pause the video and answer question 2. Okay, so one of the ways we could express the scale is just 4 centimeters to 1 meter, and we already talked about that in question 1. Another way that we can express the scale is we can express the scale as 8 centimeters to 2 meters. Notice that these are equivalent ratios. They're just other ways of stating the same relationship between centimeters and meters. Since you're at home, you can skip question 3 because you won't have a partner to discuss with. But let's dig into question 4. The actual lengths of wall A and wall D are 2.5 meters and 3.75 meters. Determine how long these walls will be on Noah's scale floor plan. Explain or show your reasoning. I'm going to get you started on the 2.5 meters problem, and then I'll have you do the 3.75 on your own. So if we know that the actual length of wall A is 2.5 meters, and we know that for every 1 meter, we need to have 4 centimeters in the drawing. So 1 meter in real life is 4 centimeters in the drawing. We simply have an equivalent ratio problem. And we can determine how many centimeters belong in the drawing to represent wall A. The reason I set up the ratio like this is because I know for every 1 meter, we need 4 centimeters, which means that for 2.5 meters, we're going to need definitely more than 4 centimeters. And if that equivalent ratio feels tricky for you, you could always think about this in terms of a double number line, just like we drew above. We know that for every 1 meter, we have 4 centimeters. So for 2 meters, we've got 8 centimeters. And then you'll kind of have to think about what might go here at the halfway points, at 1.5, and then we're looking for 2.5. And that should help you find how many centimeters represent 2.5 meters. Then you'll need to repeat the same process for 3.75 meters. That is your next step, is to repeat the process for 3.75 meters. So here's what you've got left to do. You need to finish question 4. Once you've finished question 4, you have a few other things to finish up to make up class today. Let's talk about it. Number 1 is you need to make sure that you've done scale copies in Khan Academy. This was assigned yesterday, but I know that it's a little bit of a trickier assignment. So if you need help, make sure you're watching those help videos or reaching out to Ms. Kinez. The second thing that you need to do is you need to complete the 1.9 exit ticket that's in today's folder. And the third thing you need to do is to complete tonight's homework, which is equivalent ratios in Khan Academy. So these are the 3 things left on your to-do list after you've finished question 4, which is the final problem you need to complete in Classkick. You can skip activity 3 in Classkick. And that's all. As always, if you need help, just send Ms. Kinez an email.